All right, we're going to learn something about butter guns, which is a great way to learn about something in physics called the inverse square law. And you'll see that things like gravity, sound intensity, electric force, radiation intensity obey this. And so if you can learn how these butter guns work, it's very useful. So the story goes like this. You run this company that makes buttered toasts, and the toasts come by on a conveyor belt that's a meter away, and you just spray them with butter. But then the economic times get tough and you try to cut corners, and so what you end up doing is kind of backing up the toast conveyor a little farther away from the butter gun. And so it says, well, if you could spray one toast at 1 meter, it says, well, at a distance of 2 meters, we could spray how many toasts? Well, the butter spray becomes, well, doubly tall if you back out, and then also doubly wide. So you can see kind of from the picture that if you back up 2 meters, why now you can spray 4 toasts, right? But you're kind of cutting corners. It says the customers will be unhappy. Well, because now that same butter has been spread over 4 times as much area, 4 times as many pieces of bread. So it's only going to be a fourth as buttery. You can market it as diet toast or something. Well, so just continuing with the pattern, right? If you go back 3 meters, well, now you're going to be able to spray 3 times 3 or 9 toasts, but they're only going to be 1/9 as buttery, so it's going to be really light, right? Well, so just kind of continuing along with this pattern. Well, let's try playing with this. Well, so it says the toast at 1 meter is blank times as buttery as at 3 meters. Well, so you notice here we are at 3 meters. 1 meter, you notice that you're 3 times closer. Well, if you're 3 times closer, then the butteriness is going to change by a factor of 9, and it'll be 9 times more. So 3 squared equals 9, right? Looking at the next one, it says the toasts at 4 meters are blank as buttery as at 2. Well, so again, the thing to notice here is, well, first of all, they're going to be less buttery because you're farther away. 4 is farther away than 2. But it's also, not only is it farther away, it's twice as far. It's 2 times farther. Well, if you're 2 times farther, that's going to end up being just 1/4 as buttery, right? Well, you can kind of double check. You know, if you want to do it graphically from the picture, at 2 meters we had 4 toasts, and at 4 meters we actually have 16, okay? So you have 4 times as much area. It's only going to be 1/4 as buttery. But the quick way to do it is to just see, oh, you're a factor of 2 farther, so you're going to be a factor of 2 squared or 4 times less buttery. Right. So continuing in this, it says the toast at 9 meters would be blank as buttery as at 3. Well, so what you want to do is figure out by what factor you've changed things. Well, it's like you used to be at 3. Well, now you're at 9 meters. So you're actually 3 times farther. Well, if you're 3 times farther, then they're going to be 9 times less buttery because 3 squared is 9. And so they're only going to be 1/9 as buttery. So that's the pattern. Just a couple more. It says, to make toast that are 1/4 as buttery as at 4 meters, what should you do with a butter gun? Well, now you only want to be 1/4 as buttery. Well, so you're going to be 1/4 as buttery. That's only going to be 2 times farther, right? So you're gonna want to push out farther away to be less buttery, but it's not going to be a factor of 4 because you don't want to be 4 times farther because then that would only be a 16th. And so that's the pattern. So we want to be 2 times farther. Well, so 2 times farther would be, well, 2 times your original distance. So you're going to be 8 meters away instead of 4. And then finally it says the toast at 44 would be blank as buttery as at 4 meters. Well, you're getting really far away, so it's going to be less buttery. But how much less? Well, you notice you're 11 times farther away. Well, so 11 squared is 121. So it's going to be less buttery by a factor of 121, or 1/121st as buttery. So why all this talk about butter guns and toasts? It's because this relationship, this inverse square relationship, shows up all over physics. So as we've seen, the number of toasts that you can spray with the gun, it grows like r squared, the distance squared away from the gun. So if you triple the distance, it's not 3 times as many toasts, but rather 9 times as many toasts because you have increased the area that you influence by a factor of 9. Yet the butteriness goes down by a factor of 9. So the butteriness goes like the inverse square of the distance. Well, it turns out that's exactly how things like gravity work. So imagine you have the Earth here, and what you notice is that the sort of sphere of influence of the Earth, its radius is growing, of course, as you go away from the Earth. So the area of influence is growing like r squared. And so what that means is the influence of the Earth is sort of getting diluted over a bigger and bigger area as you go out, and that's why the force of gravity falls off or gets weaker or diluted by 1 over r squared. So if you have, say, a moon that's located at a certain distance away, and then you triple that distance, well, then the force is actually going to go down by a factor of 9, just like the butteriness went down by a factor of 9 over here in the case of the toasts. Making it a little tougher maybe. So looking at these last two here, it says how far away should you place the butter gun, if you want to make toasts that are twice as buttery as at 4 meters, right? So here's kind of 4 meters, and we want to be like twice as buttery. So one way to see this is here you'd be covering like 16 toasts, and you want to be twice as buttery, so it'd be kind of wherever you would cover only like 8 toasts. So you can tell your answer is going to kind of be between 2 and 3. Well, so one way to do this is if you want to be twice as buttery, well, first of all, you need to be closer, right? Because you want to be closer to the gun to be more buttery. And you want to be closer by a factor of root 2. And so what's going to happen is you'll take your old distance, which was 4, and then you want to think about, well, do I multiply by root 2 or divide by root 2? Well, if you want to be closer, you're going to have to divide. So it's going to be 4 over root 2, 4 divided by root 2. And you'll see that you'll get 2.83 meters, which makes sense because as we were saying, you kind of want to be in a location where you'd be spraying about 8 toasts as opposed to 16. And so you get 2.83. Last one here. How far away should you place the butter gun if you want to make toasts that are 1/3 as buttery as at 4 meters? Well, if you only want them to be 1/3 as buttery, they're less buttery, so you want to be farther away. Okay, so the number's going to get bigger. We got to back the gun up, and then but by what factor? Well, we want to be 1/3 as buttery, so there's going to be a change of a factor of root 3, right? And then we just got to think about, well, do we multiply by root 3 or do you divide by root 3? Well, we want to be farther away, so you got to multiply. So it's going to be 4 root 3. And so what we want to do is be at 6.93 meters away. Then they'll be only 1/3 as buttery as at 4 meters. So this type of relationship holds for gravitation, for sound intensity, light intensity. So if you see something like light intensity, it says light from a bulb has an intensity of 8 watts per meter squared located a meter from the bulb. So if you think the brightness or whatever is being worth 8 when you're here, only 1 meter away. And then it says how far back should you move if you only want it to be 1 watt? So if you think of it being 8 here, right, and we want to back up till it's the intensity has dropped from 8 to 1. Well, so the idea is, well, first of all, right, we want to be farther away because you only want it to be 1 instead of 8. And then the idea is, well, by what factor? Okay, well, it's going to be a factor of root 8 since we want it to be 8 times less intense. So it's going to be farther by a factor of root 8. So what you'll do is you'll multiply your original distance, I guess, of 1 meter. You're going to multiply that by root 8. So 1 root 8 will be 2.83. So now to just check that this makes sense, you notice when you were here, the intensity was 8. If you went all the way out to 3 meters, then the intensity would be 1/9 of what it is. Well, we only want it to be 1/8, not 1/9. So it should be like almost to 3 meters, but not quite. And you notice that kind of jives with our answer here that you back this thing up to 2.83 meters. So that, my friends, is butter guns or inverse square laws. Like I said, gravity works like this. Electric force works like this. If you're 9 times farther, the force is only 1/81st as big. If you're 5 times closer, then the force would be 25 times bigger. So that's how electric force, gravitational force, light intensity, sound intensity works. So it goes like butter guns.